So now we'll solve a frame problem using a stiffness method. Here is the question. We have a one, two, three, four, four frames related problem. Uh, so now we'll solve a problem of a frame using stiffness method. So the very first step is to find out the fixed end moments. So we'll attach a fixed support in every joints we have, then we'll find out fixed end moments. So let's do that. Let's draw a fixed end here, fixed end, another fixed end here, fixed end. So all the joints and supports are fixed ended. So now for the load 30 kib here, we'll get a moment here, we'll get a moment here and here. Same moment as it is in the middle. So the moment will be 30 PL, where P is 30 and L is 40 PL by 8. The value will be around 52.5 cube feet. So the value is 52.5 for both the moment. We'll get another two moments for this loading for keeper feet along the frame. So we'll get a moment this way and this one. The moment will be WL square by 12. Here W is 4, length is 14, WL squared divided by 12. The value will be 65.33. 5.33 if I'm not wrong. Yeah, this give it 65.33. Later, we need some reactions as well. Say here the reaction will be this direction, and here the reaction will be in this same direction, and the reaction will be half of 30, which is 15 kb. Here we'll get reaction this way upward, and the reaction will be 4 multiplied by like something like that. 4 multiplied by 14 divided by 2, so it will be 28. So these are the fixed end moments and reaction. So now this was our very first step, which is to find out fixed end moment. Our next step is to find out number of dokis, and we'll apply doki one by one. And before that, we have to like figure out how many dokis can be applied. At point A, no doki can be applied. Horizontal, vertical, or rotation, nothing is possible at point A, E, and D. But B and C, we can apply a doki like this way. Uh, Along the frame BC, a lateral movement is possible. Let's say we are getting a movement of like that this way. The frame is going along this direction, which is the lateral movement. Let's call this Doki U1. Later, it is very much possible that a rotation is possible at point C. Let's say a anti-clockwise rotation we are applying. We call that U2. At point B, a rotation is also possible. Let's call the rotation U3. So the number of Doki is 3. We will apply them one by one. First of all, we will apply the Doki U1, which is lateral displacement of the frame BC. Well, let's draw the frame once again. So let's say this is our frame. So this is our frame. So we are applying lateral displacement of this point, which is B. Isn't that B? No, not B. The point is C. So this is C and this is B. It will move laterally. Let's say it will come to this point after lateral displacement. So the B will move this way. Let's say up to this point, exaggerated thing, this point. Now here, this is the fixed end joints. This is the same thing. So now a joint of 90 degree will be remains like that. The joint will act like that. Here, the joint will act like that. At support, it will not deflect a little bit. So the deflected shape will be like that. Here it is the same thing. It will be like that. Here it will be like that. The deflected shape will be like that. Now, from here, the shape will be like that. There will be no deflected shape along this plane BC, because it is at 90 degree, it is at 90 degree. So no deflected, so this is the deflected shape which is are already here. So for this deflection, we for this deflection we'll have some moments at the joints, internal joints. Let's say we have applied Doki E1 is 1 unit displacement. Now the moments will be now the moments will be uh, I'm showing you a formula, standard formula. Let's say it was our standard frame and which has been displaced to this point. So let's say it has been displaced at a unit displacement of E1, this displacement. So how much will be the moment and how much will be the uh, reaction? The if the displacement is in this direction, which is clockwise, the moment will be anti-clockwise, like that, moments, and the moments will be 6 6 ei over L squared multiplied by the displacement happened, so E1. And the reaction will be, if the moment is in the direction of let's say anti-clockwise, the reaction will be clockwise, and the value is 12 multiplied by ei E1 over L cubed. So we'll apply this formula in this frame. Let's say we're considering this point. Say the displacement is occurring in this direction, which is uh, anti-clockwise. So we'll apply clockwise moment, which is this, which is this. The moment is 6 EI over L. Here the L was 16, 16 squared E1, and the reaction will be in this direction, in this direction, and the value is 12 EI over 16 x cubed E1. For the lower frame here, the displacement is like that, which is clockwise. So the moment will be anti-clockwise, like that, and the value is 6 EI. Here the EI was twice EI, so it will be twice EI E1 over, and the length was 18, 18 squared, and the reaction will be, and the reaction will be this direction, this direction. The reaction will be twice EI multiplied by E1 over 18 cubed. For this frame AB, the displacement is occurring in clockwise direction, so the moment will be in anti-clockwise direction. Let's say this direction, and the value will be 6 EI E1 over L squared. Here L is 14 squared, and the reaction will be this way, and the reaction will be 12 EI E1 over 14 cubed. So these are the moments and reactions we are getting after applying the Doki E1 is equal to 1 unit displacement. Later we will apply our Doki U2. Okay. Now we'll apply our Doki U2. So let's draw the frame. This is our frame. Something over here. Well, our U2 was a unit rotation at this point, which is C, point C. We'll apply a unit rotation at point C. So at point C, if we apply unit rotation, so initially it was like that. So after applying unit rotation, and the support or the joint will be like that. The joint will be like that. Let's draw it a bit exaggeratedly. It will be like that. It will be like that. So how do we draw the deflected shape? Uh, at this point, uh, it will go like that, and it will come like that. And here, it will remain like that, and it will maintain a 90-degree angle here with this joint. So it will become like that. For this frame, uh, it will remain like that. It will remain like that. So this is the deflected shape. This uh, A B will not be deflected since it is maintaining a, 90-degree shape here in already at point B. So these are the deflected shape after applying the Doki U2 is equal to 1 unit rotation. So what are the moments and reactions? Let's find out that. So here we have applied a anti-clockwise rotation. So all the moments will be in anti-clockwise moment. So here the moment will be like that, and this value will be 4 ei u2 over L. Here the L was 16, and this moment will be half of it, which is twice ei u2 over 16. Later, for the lower frame here, uh, the moment will be anti-clockwise, so it will be like that and that, and the value will be 4 ei. Sorry, it will be twice ei. So it will be twice ei, twice ei. It was given twice ei u2 over, here the length was 18. It will be half of it, which is twice into twice ei u2 over 18. And for that, we'll have a reaction a moment this way, and the value will be for this point here. It will be 4 multiplied by twice ei u2 over the length, and the length was 14, and it will be half of it, which is twice multiplied by twice ei u2 over 14. There will be no moments along this frame, which is AB. So now we need the reactions. So what will be the reactions? The reactions will be uh, this way and this way, and the value will be same, which is 6 ei u2 over 16 squared. For that, the reactions will be like that, and the value will be 6 multiplied by twice ei u2 over 18 squared. For that, the reaction will be like that. If the moment is anti-clockwise, the reaction will be clockwise, and both reaction will be same, which is 6 multiplied by twice ei u2 divided by the length squared. Here the length is 14 squared. So these are the possible moments and reactions after the application of the Doki U2. Now we'll apply the Doki U3. So we have a frame. Let's redraw this. Okay, the frame is drawn. So we now we'll apply our Doki at point B here, this point. We'll apply Doki at this point B. So if we apply moment here, initially the support was like that. So if we apply Doki, let's say anti-clockwise and like that, how it will behave? This fixed support will get inclined, isn't it? So it will be inclined like that, like that. It's a bit exaggerated, and the deflected shape will be like that. no doubt, like that. And for that, the deflected shape will be like that. Here, see, a 90-degree angle is maintained at joint B. A 90-degree angle is maintained at point C. A 90-degree joint is maintained at point A. So everything is fine and no other deformation will occur. So what will be the moments? Here, as we have applied the anticlockwise rotation, we will get anticlockwise moment. So for this point B, anticlockwise, anticlockwise, and the moment here will be 4 multiplied by twice EI, twice EI, U3 over L. Here the L was 14, and the moment here will be 2 multiplied by twice EI, U3 divided by 14. At point A, we'll get a anticlockwise moment like that, like that, and the value will be here. It will be like 4 multiplied by EI U3 over the length. Here the length was 14. If I'm not wrong, it was 14. Yeah, it was 14. 14, and it will be twice EI U3 over 14, and the reactions will be for that the reaction will be upward, it will be downward, and the value will be 6 multiplied by twice EI U3 over the length squared, which is 14 squared. Another thing that is for the frame AV, the reactions will be this way and this way, and the value will be 6 EI U3 over the length, which is 14 square. So these are the moments and reactions after the application of Doki. U3 is equal to 1 unit rotation at point B. So we have applied all the Dokis. So now we'll form equilibrium equation. We need three equilibrium reactions, since we have three unknown Dokis. So at what points we'll apply our equilibrium equations? So we'll apply our equilibrium equations along the frame BC, since we applied our first Doki displacement along this frame, which is BC. We'll apply our second equilibrium equation at point, say, C. We'll apply our third equilibrium equation at point B. Then we will solve the equilibrium equation and we'll find our unknown Dokis. So let's apply. So we are assuming uh, force along the frame BC, external force along the frame BC, and internal force along the member or frame BC is same. So otherwise it won't act like a stable structure. So what was our external force? Let's go back to our problem. What is our external force? Our external force along the frame BC was 25 kip. It was our force, and 45 kip it was our moment. So since we are not considering moments, we are applying only force along this frame BC. Our external force is 25 kip. It was in right direction, so we are taking right direction as a positive direction. So the 25 will be a positive 25. So it's a positive 25. So what is our internal force? Our internal force, let's go to our first figure, what is our internal force. So this was our first figure. So along this frame BC, we have a internal force of 28 kip, no other force here along this frame BC. So we have one internal force of 28 kip. So it's left directed. So we're taking left directed as negative. So we're getting minus 28 internal force minus 28. We have got to minus 28 for fixed end moments case. Now we'll look at our this figure. So now we are getting a few other reactions. So one reaction is this, one reaction is this, another reaction is this, another reaction is this. So so many reactions here. So we are getting three reactions uh, after the application of Doki E1, which are 12 EI for 16, 16 cubed. Another one is another one is 6 multiplied by 2, which is 12 EI E1 divided by 18. It will not be 18. Sorry, this was our reaction. So 12 multiplied by 2 EI multiplied by E1 divided by 18 cubed. So this is our second reaction, and the direction is right directed, so it will be positive. It will also be positive, which is 12 EI over 16 cubed multiplied by E1. And this reaction here, which is 12, hopefully it's written as 12, 12 EI E1 divided by 14 cube, which is in right direction as well. So after the application of Duki E1, all the reactions is right directed, so it will be a positive reaction. So 12 EI over 14 cubed. Another one was 12 EI over 16 cubed. Another one was 12 multiplied by twice EI over 18 cubed. And there were the dokis of U1. So after these are all the reactions we are getting from the application of the Doki E1. Now we'll find out the reactions what we got for the application of Doki U2. Let's go to our second Doki. It was our first one and it's our second one. So what are the reactions we're getting from here? So it's our one reactions, it's another reaction. So two reactions. One reaction is 6 EI U2 over 16 square, and another reaction was 6 twice EI U2 over 18 square. So two reactions are getting from the Doki here. So yes, let's find the reactions what we got for the application of Doki U2. So it was the Doki U2. So we got a reactions of 6 EI, 6 6 EI U2 16 squared. So here it's actually 6, not 12, because uh, for a unit rotation here, so let's say it got a form like that. So if the moment here is 4 EI, let's say U2 over, let's say L, the moment here will be the half of it, which is twice EI over L U2, and the reaction will be same, but the reaction will be the reaction will be 6 EI over L U. So this is another formula for unit rotation. So here the reaction is 4 EI U2 over 16, which is left directed for this frame, and we have another reaction which is 6 multiplied by twice EI U2 divided by 18 squared. So, will that be squared? Yeah, it will be squared here. It will be squared. So twice EI U2 over 18 squared. It is right directed. So this one will be plus and this one will be minus. So here the formula will be plus 6, no 16, plus 6 multiplied by twice EI. I'll write U2 as common, EI over L, which is 18 squared multiplied by 6 multiplied by EI over 16 squared, and all of them have a common multiple of U2, plus the reaction we got for the application of Doki U3, which is this. So for the application of Doki U3, we got a reaction of this, which is 6 EI U3 14 squared, and it is right directed. So the value will be plus 6 EI U3 over L squared, which is 14 squared. So this is our first equation. So we'll get to another equation for the application of Doki U2 and U3. So let's find them out. So let's say at point C, summation of moments is equal to zero. So we have let's say external moments and internal moments. At point C, we have a external moment of 45 feet. It is given, which is this, and it is clockwise. So the external moment is clockwise 45 feet, and is negative since we're considering anti-clockwise moment as positive. So we have got a moment of 45 feet as external moments, and it is negative. It is external moment if the right hand part. Now we'll write internal moments in left hand part. So whatever the internal moments at point C. So for fixed end moments, we have internal moments of something 52 point 52.5, and it's clockwise. Since it's clockwise, so it will be minus 52.5. So it will be minus 52.5 minus 52.5. So what are the other moments for the application of Doki E1? Got a moment of we've got a moment of it is clockwise. So the 6 EI 16 squared E1 is clockwise, so it's minus. We have another moments of 6 twice EI E1 over 18 squared. It is anti-clockwise, so this is positive. So these are the two moments we are getting at point C after the application of Doki E1 is equal to 1 unit rotation. So we'll write that under U1 page down. So we'll give a plus sign and we'll write 6 multiplied by twice EI over 18 squared minus 6 EI over 16 squared. We have a common Doki of U1. For U2, we have some other moments. We'll find that. So for the application of Doki U2 at point C, we have the moments. We have the moments. Whatever the moments we have got? We have moment this, which is anticlockwise, hence is positive. We have another moments of 4 EI u2 over 16, which is anticlockwise hence positive. We have another moments 4 multiplied by twice ei u2 over 14. So these are the three moments we're getting at point C after the application of Doki u2. So under this, we'll get a moment of 4 ei over 16 plus 4 multiplied by twice ei over 14 plus 4 multiplied by twice ei over 18. All the moments are under the Doki u2. So we'll get another moments at point C, which is this 2 multiplied by twice ei u3 over 14. So we have got another moment which is twice multiplied by twice ei u3 over 14. So this is our second equation. So we'll apply another moments at points B. So the external moments and internal moments will be 0. So at point B there is no external moments since it's 0. So what are the internal moments? At point B, internal moments was at point B 52 point is that 6 or 52.5, which is clockwise hence negative, and 65.35, which is in 65 sorry 52.5 is anti-clockwise hence positive, and 65.35 which is clockwise hence negative. So these are the moments we got for fixed end moments. So we have got 52.5 positive and 65.35 negative. So after the application of Doki E1, what are the moments we got? So after the application of Doki E1, we got the moment of 6 EI E1 over 14 squared this. So only one moment, which is 6 EI E1 over 14 squared. So what are the moments we got after the application of Doki U2? Let's go to our previous picture. So we got U3 is equal to 1. So we got like one moments, which is twice multiplied by twice EI U2 over 14. And it was anti-clockwise hence positive, plus twice multiplied by twice EI over 14 U2. So what are the moments we got after the application of Doki U3? We got two moments, which is 4 EI U3 14, which is anti-clockwise and positive, 4 EI over 14. Another one is 4 multiplied by twice EI. Another one is 4 multiplied by twice EI over 14. So these are the moments will remain under U3. So this is our third equation. So if we solve for U1, U2, U3, let's say we have U1, U2, U3, and one constant. So we'll write all the values under U1, U2, U3, and another will be constant pair. If we solve three simultaneous equation, we'll find out the value of U1, U2, and U3, and the value will be U1 will be equals to 5092.78 Ti. If you find it troublesome, let me know. I'll explain how to solve it using calculator. 12 point hopefully it's O2 over EI, and U3 will be minus 162.88 over EI. So these are the moments, sorry, Doki we have got. If you want to find out any moments, you can easily find out once you have got the doki found. Let's say at point A, let's say at point A, you want to find out the moment. Let's say this, for example, like you want to find out the moment AB. How do you do it? You'll go to the first picture, very first picture, which is this. You have a moment of is that a moment of reaction? So you have a moment of 65.35 and it's anti-clockwise. So from the first picture you are getting 65.35 for fixed end moments. Oh god. So it is 65.35. So later you will go on the next next thing, which is Doki. Did you got any moments at point A? Yeah, you got a moment of, I can see it. Uh, let's, it's 12 EI EY 16 squared. So you have got another moment of 12 EI EY 14 squared. So is that a moment? Or sorry, the moment is this, which is 6 EI E1 14 squared. The other one is reaction. So so from the Doki E1, you're getting a moment of 6 EI 6 EI over 14 squared E1. So this is another moments you're getting for the application of Doki U1. So what are other moments you're getting for the application of U2, which is second moment? Second Doki, you will not get anything because for the Doki U2, you are not getting any deflected shape at this frame AB, so you have got nothing from here. But from the Doki U3, you will get a moment of 6, twice EI U3 over 14, and it's anti-clockwise, hence positive. You will get twice, twice EI U3 over 14. So now you know the value of E1 and U3, and E1 is 5092.78 over E1, and U3 is minus 162 point, is that I think 888 something EI. So EI will cancel each other, EI will cancel each other, here will cancel each other, and you have minus 162.8 will be multiplied here, 509.2.78 will be multiplied, and you will get a value from it. So this is how you get the value of moment after solving the Doki E1, E2, and E3, and you can find out the reactions of any joints following the same process. So